Juice seller was serving his customer using glasses as shown in figure. The inner diameter of the cylindrical glass was 5 cm. The glass is in the form of the cylinder and the diameter is 5 cm given. But the bottom of the glass had a hemisphere raised portion which reduced the actual capacity of the glass. The glass is in the form of the cylinder and in the bottom there is a hemisphere raised inside it. So it reduced the actual capacity of the glass. That is given. If the height of the glass was 10 cm, that is h is equal to 10 cm given. Find the apparent capacity of the glass and its actual capacity. Find the apparent capacity. What is apparent? Apparent is that seems to be real or true but may not be true. So that is the apparent capacity of the glass, because the actual glass, there is also a hemisphere inside raised. So the actual capacity will differ because of the hemisphere. So first we have to find the apparent capacity of the glass and we have to subtract the hemisphere part from it. Volume of that hemisphere from that glass, and that gives the actual capacity to us. So actual capacity will be apparent capacity minus the hemisphere volume. Okay, volume of the hemisphere. So we have to first find now apparent capacity, then we have to find the volume of the hemisphere, then we'll find the actual capacity of the glass. We'll go to the solution. Since the inner diameter of the glass is 5 cm and height is 10 cm, that is given. So radius will become, that is half of the diameter, that is 5 by 2, that is 2.5, which is equal to pi r square h. That is volume of the cylinder is pi r square h. We know that pi r square h. So here pi is equal to 3.14. R is equal to 2.5. That is 5 by 2. That is equal to 2.5. What is pi? Pi is the diameter. Radius is half of the diameter. That is 5 by 2. That is 2.5. And h is given. That is 10 cm. So we will substitute these values in this formula. So pi r square h is equal to 3.14 into 2.5 into 2.5 into 10, which is equal to 196.25 cm3. Now we will find the volume of the hemisphere. We know that volume of the hemisphere is 2 by 3 pi r cube, which is equal to 2 by 3 into 3.14 into 2.5 into 2.5 into 2.5 centimeter cube, which is equal to 32.71 meter cube. Now we will find the actual capacity of the gas. Actual capacity, as I told you, we have to subtract the volume of the hemisphere from the apparent capacity of the glass. So actual capacity of the glass is equal to apparent capacity of glass minus volume of the hemisphere, which is equal to 196.25 minus 32.71, which is equal to 163.54 centimeter cube, and that is the solution.